Hello, everyone, and welcome to today's CDCT live session. My name's Jason Rader, and I'll be your host for the next few minutes as we dive into the topic of AI. And we've got some really special guests with us today. First off, we have Juan Orlandini, who's CDCT's chief architect. Second, we have Kyle Wallace, who's a lead architect at CDCT with me. And then we have our special guest from AI, Tony Paikeday, who's a senior director of AI systems with Nvidia. Welcome, gentlemen.
Good morning. Thank you. Good morning.
Good morning.
So this is really exciting. I'm happy to jump into this topic, and I know a lot of the folks out there listening are as well. So I know we're going to get into some really cool stuff, but let's start high level if we can, and talk to me about AI in general. What are we talking about when we say AI?
Well, I'll take the first stab at it, and then Tony or Kyle, if you guys don't mind jumping in. So AI can mean a lot of different things, and it actually, and the way people are throwing it around is actually mixing both machine learning and natural language processing, all sorts of different things, right? And what we really are talking about is a class of algorithms that what they do is accelerate the prediction of some sort of an event that happens, all right? And those could be some pretty sophisticated things. They've been all over the news. Like there's algorithms that can predict next move in a chess game or the next move in a Go game. So that could potentially be AI. But there's also better things like and we'll talk about some of these use cases, like being able to analyze X-rays and do better predictions of diagnosis, right? There's all sorts of different things that it can be leveraged against. But the important part is that you have a bunch of data, an algorithm that processes it and gives you a model, which is kind of a sort of another different model that can then take new data and say, based on what I've seen before, my model tells me that this thing is likely to be that thing, okay? And that's just the general thing. So it requires a lot of compute, a lot of storage, a lot of infrastructure, and a lot of smart people to make happen initially, but then brings a lot of business value afterwards. Is that a good summary, Tony?
Yeah, I think that's great. I think you hit the nail on the head there, Juan. To add just a little color there, another way I like to think of this is that AI is really good at finding the proverbial needle in the haystack, right? If you are trying to find that one fraudulent transaction amongst millions, if you're trying to determine if that spot on that MRI image is cancerous or benign, if you're trying to find some kind of anomaly that's buried in oceans and oceans of data, that's what AI is really good at. And Juan, really hit it there, because at the core of this is really detecting patterns in data and understanding which patterns or features in that data are meaningful to a problem that you're trying to solve. So AI basically can take what in human terms might be worth decades and decades of raw experience in school, on the job, or what have you, and shrink that down into minutes or hours of what we call algorithm or model training, right? And so with that capability now, we can do some pretty superhuman things as a result. So I think more and more we're finding organizations using AI to find those needles in the haystack, to find those anomalies, to make better decisions. And another way to liken this is that where we used to hard code a lot of these things with millions and millions, maybe billions of lines of code, AI replaces all of that, because the new code, the new source code for the modern enterprise or agency is essentially data. That's the root of all of it.
Nice. And go ahead.
One thing I'd like to point out, and that I think is an interesting topic for us maybe to dive into, and Kyle, you've seen this in practice, is that there's a misconception that AI requires new data. So the camera sensors on a moving device, or a new, spectrometer, or some new, whatever it is, right? But in fact, what we found is that there's treasure troves of information that are scattered all over agencies, all over data centers. And what we need to do is coalesce a lot of that data together and then extract more new value out of it. And that's actually something that's one of our big focuses is that, hey, you have all this data, are you getting the most value out of it? And that's where AI plugs itself in, right?
That's really about learning from data and providing, meaningful results that the business can act on, right? And so, you mentioned some healthcare examples like early cancer detection and radiology, and manufacturing for inspections and quality control, fraud detection. Tony mentioned are all areas that can benefit from AI.
So that's a really cool setup for kind of, I think, where we need to go from the conversation perspective, right? So we see the benefit, we see the leaps and bounds that we've come based on the logic that's been created. Now it's accessing all of that data and then evoking the performance that we need out of this data to be able to do whatever it is from a business perspective that we have to do. And I think my next question would be, what's the state of this in the normal enterprise situation right now?
So it's interesting, all right? Doing this at any kind of scale is actually kind of challenging for an organization because it's new. And it doesn't matter what sector you're in. It could be public sector, it could be in commercial. AI is relatively new. And so what there is, at least in the commercial sector, there's a big push to try these things out and just go see what's possible. What can I do, right? And what they're doing it with is the public cloud, right? Which one of the challenges with doing it in the public cloud is that your data that you're trying to learn from might not necessarily be already in the public cloud, all right? So what they do is they slice out a little small chunk and move it up to the public cloud and try to learn from it. And that's cool, but the power of these algorithms is directly driven by how much data you feed them, right? So if you're slicing out a little chunk and you're giving it to this thing, it's going to give you good values, but then you're going to at some point have to train it or use the rest of your data sets, all right? So what we're finding is that there's a lot of use cases where they use the public cloud, they consume that stuff, they train it. The nice thing about the public cloud is that they already have some pre-trained models that you can just use. You don't have to go train yourself, right? Say if you want to do something like object detection or counting people in a line or whatever, that's literally just a few lines of Python or whatever programming language you want. It calls it, you give it the object, and it gives you back, there's 27 people in line, right? But there's other use cases where you actually have to go train the model yourself. And that's where we're finding that the public cloud starts having challenges. That there's a heavy duty cost. The GPUs are not inexpensive. They're being constantly used. They're very, very expensive. Storage costs can become extremely expensive, especially if you're having to shuffle the data back and forth and all that. That's in the commercial side. In the public sector side, there's some agencies that do not want to have their data in the public cloud, right? Or cannot have their data in a public cloud. And so what they want to do is leverage some of that same kind of technology, but on premises. And that's where Nvidia actually comes in with a bunch of technology, both in terms of hardware that accelerates that learning process, as well as software that actually drives that whole innovation experience that you're trying to pursue, right? And you do it on premises, all right? So, and it comes in different sizes, by the way. It comes everything from a small card that you can buy off the shelf at your local hardware provider, all the way to what they call these workstation class servers that are literally look like another PC that sit under your desk, but are actually supercomputers. And then on into what's called the DGX systems, which are the server class systems that you can scale to essentially infinite computational capacity, right? So I don't know if I answered your question. I went on a little ramble like I normally do.
Yeah, we've come to expect that from you, Juan, but that's okay. So Tony, from Nvidia's perspective, it sounds like there's a commercial play in here for those folks that are getting that fatigue from either not being able to get enough data up into the cloud or or dealing with the cost associated and not being able to realize all of the results because the gravity of their data is actually on-prem. What are you guys doing? Is there anything to add from what Juan's kind of talking about the Fed side, commercial side that Nvidia is kind of tackling?
Yeah, we're intently focused on enabling kind of this continuum, and Juan kind of hit on this because there's lots of modalities through which you can get computing capability to solve your problems, right? And I liken this to a journey. There are folks who, for instance, begin in cloud because of effortless access to resources. From the Nvidia perspective, it's very important for us from the very first time somebody decides to research what is deep learning and decides to learn about frameworks and different models and use cases, we want them to have a great developer experience using the tools and the full stacks that we've built in every industry that you can think of. And our mission is to make it incredibly simple for any developer, whether they're part of a very ultra large organization or a PhD student trying to build something new, right? But our mission is to ensure that from where they start to ultimately where they end, which may be in a large enterprise building some mission critical application that's running an entire business, we want them to be able to have this effortless, highly productive experience, which is why we've invested both in hardware, in the silicon, right? But just as much, maybe even more, in the software, because so much of the innovation in AI happens at the software layer. And hardware alone can't do it. We've seen, for instance, 10 months go by where the performance of one of our systems, one of our DGX systems, has more than doubled. And in that time, no change in the hardware has happened, but the software stack running on it has seen immense innovation. And that's the nature of this space. So our job has been to enable this seamless, productive experience, no matter where you're at in your journey, whether you're doing early productive experimentation to building early prototypes to training and inference at scale in a large enterprise or public sector type environment. We want it to be this effortless mobility of your data and workload from one to the next, because that's essentially the journey that everybody's on.
Yeah.
And part of the I'm sorry, Jason. Part of the journey that you didn't cover on that, Tony, is the edge itself. And Nvidia has actually invested quite a bit on the edge. And by edge, I mean sensors out in the field, sensors out on a mobile device of some sort, right? It could be a car, it could be a truck, it could be a tank, it could be whatever it is, right? And the end-to-end experience is actually reflected across all of that. So it includes the edge device, the near edge device, which might be doing some pre-processing before sending to a data center, and then the data center itself. And the full stack has actually been enabled by Nvidia. And that's actually really exciting because one application process drives it completely from the sensor itself all the way to the data center and the modeling and training itself.
Absolutely. You take a great model that you've built and trained in the data center and then optimize it for deployment at the edge. And now we have all these different modalities, as you mentioned, at the edge, whether it's a robot on a factory floor or a sensor on a piece of industrial equipment or a jet fighter for that matter. And essentially, we want to be able to run inference, right? The production application of that great AI model that you've built right where the data is, right? Bring the compute capability to where the data lives or is being created, derive answers, and then there's this kind of virtuous loop, because over time, as you see newer and newer data, you probably realize that your model needs to evolve, and you bring that model back to your data center or where your AI center of excellence is and build the next generation of that model. And it's this virtuous loop. It goes over and over again. But yeah, it's a complete end-to-end approach, if you will, yeah.
Yeah, and it applies to even things like smart cities or any of those kinds of things where you're trying to capture more data and process it efficiently so you can have quicker response to events of any kind that you're trying to monitor, right?
So,
yeah, and I think if you look at like an industry like oil and gas, they'll even do their training right out at the edge, because they're generating so much data at those drilling locations. That even edge training is a possibility now.
Yeah, that's like the literal and figurative meaning of oceans of data, right?
Nice. And so let me reel this back in just a minute, because I think we talked about a lot of really cool stuff. And I really love the point you made, Tony, about the software being just as important as the hardware. That really kind of opened my eyes, from a development perspective. That's super interesting. But Kyle, you're on the front lines of this all the time, right? So we've talked about smart cities and backing up into what are the conversations that clients are having with you? Are they engaging with you more of tell us how we can leverage this stuff, or they've already kind of made up their mind and you're helping put the infrastructure and the pieces together for them?
I'd say in my role, it's more of the latter. I think probably in Tony's role, he's probably talking to both, but we're helping IT figure out how they can help their organizations embrace AI. And so, just like other modern applications, AI training and development is done, with containers primarily. So whether that's in the cloud or on-prem, IT needs to be able to, manage and operate those containerized workloads and get really good at doing that. So typically that's going to be, Kubernetes for the orchestration layer, but also to include traditional data services, such as data protection, security, and monitoring. So we're helping IT organizations, you get ready for AI and make sure they're able to operate those environments effectively.
No, I think that's great. We always everything evolves back into the role that IT kind of plays in all of these kind of transformative type of initiatives for organizations, but it still kind of boils back down to the way that IT is going to enable that for their internal clients to be able to take advantage of these things.
That's exactly right. And it's, one of the sayings that we have within Insight is that you can't do digital transformation without a modern platform, right? And so modernizing the platform itself. And what Kyle just talked about is exactly that. You have to modernize how you do your compute, how you manage that compute, and then how your developers can consume that stuff. And the developer experience is front and center of that, because there's this group of people called data scientists, right? They're the ones that have PhDs and they're super smart, and the words that come out of their mouth make sense to me, but not in the order that they give them to me, right? They're really, really smart, and what they want to do is focus on how to solve a problem. Right, they're really their time to value is incredibly important. They need to see, hey, I have this challenge or mission that I've been given. How do I get to the end state as fast as possible? And then there's a data prep group that helps them do that, and then there's IT that supports all of that stuff. And if any of those is not operating as efficiently as possible, then the data scientist is not going to be able to achieve mission as fast as possible. Right, and that's what Kyle and team are really doing, is building the systems so that the rest of the smart people that are consuming this stuff can actually do it as efficiently as possible.
I'd really like to lean into this role of IT thing, because it's so important what you guys are talking about and what you're doing for the organizations you're supporting. And, this is one of those invaluable situations where IT gets to position itself as an enabler of business strategy, not just like a cost center.
Mm-hmm.
And one place that IT can lead, it's in leading with a platform and an infrastructure strategy for AI. And if you look at all the great use cases that we've been talking about, all the great work that's been done in organizations, a lot of them were operating outside of IT, which is kind of scary. I mean, this is what I'd call, shadow AI, if I can give it a name. And, well-meaning business units standing up infrastructure because they couldn't get the resources they needed from within, largely because AI is unique in how it consumes resources and how the workflow is transacted. So many IT leaders might survey their landscape and see lots of these discrete innovation silos that could easily be replaced with a centralized shared infrastructure. And many are doing it using, our DGX platform, guided by strategic partners like my friends here, right, from Insight. And if they do it, they'll see additional benefits like consolidating expertise and best practices, in addition to reducing OpEx. And that's OpEx is maybe escalating in the cloud, under people's watch, right? And One other thing is this is a great way to create a center of excellence that can groom data science talent from within versus trying to hire it externally.
Yeah, it's a good point. Another benefit of doing that as well is one of the things that we've seen is that researchers can't get the compute power from traditional IT either fast enough or period, right? They're looking for these GPU accelerated things. So they go and buy a commodity off the shelf like maybe a Titan class GPU, right? Something that you would put into a gaming PC, and they're using those things. But then you give them access to something like the A100, the VGX class box, and their research goes from one generation a week to one generation every couple hours, and their mind is blown, right? And the really valuable thing about that is that you can share that amongst multiple researchers and still accelerate all of their value. So that's part of the other thing, that there's this shadow IT controls is really good. But you're not controlling and taking away something, you're controlling and giving more power back. And that's actually a huge value.
So you guys brought up something that's kind of interesting to me. And again, we have different levels of folks that watch these kind of videos, but from the business perspective, from the C-level perspective, what I'm kind of thinking about is, it sounds like an investment, even in a time where economics is something that we've got to pay very close attention to, an investment in something like this, to your point, Juan, to be able to accelerate what we're doing already, or to your point, Tony, to make it so that there's a central platform to make it easier for us to advance. Those seem to be really smart business decisions that could be driven from the top down as well as from the bottom up, like we were just talking about.
That's absolutely right. And I'll tell you, even in times like today, where it's really critical that we can do some computational modeling of protein structures, viruses, and those kinds of things, and maybe the acquisition cost for this thing is actually supported by that specific thing, that same technology can be used for an AI model. So you don't have to just do AI on one of these GPU accelerated servers. You can also do modeling. You can do a lot of other things that are actually of tremendous value. And if you have a center of excellence where you have these resources available, you can share them amongst researchers that are doing different missions, right? You might have one that's trying to figure out a better way to manage a city, and another one that's trying to figure out how to model the protein folding of a structure. And they can share the same resource and do it very, very effectively.
Even internal security.
That's absolutely right. Yeah.
One thing for those who are hearing what Juan is saying and wondering, they're kind of sitting on the fence, like, is this really the time to do this? I just say now more than ever. I mean, if you look back at previous challenging periods in our recent history, including like 2008 and even back to 87, well-managed organizations did three things really well, right? They drew customers closer and solidified loyalty. They streamlined operations and saved costs everywhere possible. And maybe more importantly, they used the downturn or this difficult period to create competitive advantage. And this is where laggards fail to see, I think, the opportunity to evolve. It's like, brick and mortar retailers missing the e-commerce wave, or video rental stores missing streaming, or bulb manufacturers missing LEDs, right? This is when companies can actually use AI to create a first mover advantage. So now's a great time to be thinking about recommender systems if you're running an online customer service operation, or sentiment analysis, or predicting customer churn. And it's a great time, especially in industrial settings or federal or public sector settings, to be thinking about equipment uptime, right? Or forecasting inventory better, or parts planning. So now, embrace AI now, because without a doubt, others are.
That's actually one of the use cases that we have, where there was one of our clients makes large refrigerant for buildings, air conditioning systems, for lack of better terms. And the way they used to service those systems is they would dispatch a crew on a regular basis. And sometimes they would dispatch them a little bit too early. Sometimes they would dispatch them a little bit too late, and more in a reactive fashion. But they really didn't have a good sense of how the data was actually driving better maintenance, and actually a better overall experience for their clients. And we help them instrument these systems. All that data flowed into a central repository, and then once we had the data, we could start doing some really smart things, some predictive maintenance, some trending, some capacity planning, some all sorts of different use cases that came out of it. And oh, by the way, there were some great visualizations that we could all of a sudden show. So their support centers could now see a world map with all of their installations, with red lights and green lights and all that stuff, and dig into it. And all of that was enabled by making sure that we had the right data, and then we had the computational power to manipulate it so that we could get new insights out of it. And that is true across, I don't care what you do, as long as you can do that, you can get new value out of it, right?
I think that's been kind of one of the age-old problems, that now it's not as much of a problem anymore, right? I remember being in a position several years ago, maybe more than a decade ago now, where there was information that we had to process, but it took more than a day to process that information, but we needed to act on that information as quickly as possible. And every day put us that many more hours behind. And again, leaning into a modern platform right now, to your point, I love talking about those different iterations that have to happen as you're working towards whatever goal you're trying to get to be able to do those so much quicker. And I think it's abstract to folks when they're kind of buying those off the shelf, video game cards, if you will. I mean, I do want a 3090, by the way, but that's a whole nother story.
You and me both. And like a million other people.
We'll have another session just on that. But those people that are kind of getting a touch of it, you've got centers of excellence within your organization that don't have the right tools to lean in from an innovation perspective. Because I know internally we did, during this time where we had a lot of downtime, we did a lot of internal innovation. If we didn't have the right platforms to do that, we'd be not getting as far ahead with that investment that we could have been.
Yeah, I think Tony hit the nail on the head that, now is the perfect time really to invest in those technologies that allow your business to come ahead when we come out of this, right? To go after your competitors, improve the products and services you offer, because if you don't, they're probably going to do it instead, right? So the other point I'd add is that I think it's really important for IT to be really, really tightly integrated with the business. It's always been important. But AI is about solving business problems. So IT needs to be sure they're in lockstep with what that business strategy is, so that the products and services that they are producing are aligned with that.
No, I love that. Can you elaborate on that, Kyle? Because we kind of say that a lot, where IT can get kind of, if they're not talking up the types of solutions or ways that they can partner with the rest of the business, they can be, some folks at the top that don't understand really can kind of think, oh, we can just kind of replace these guys with this infrastructure in the cloud or something like that. What's some advice you would give to those folks that are sitting in those roles right now that have the desire and the know-how to do this? How are they more meaningful to the organization?
Yeah, I mean, I think we touched on it earlier about being able to provide the types of infrastructure and services that the business needs, while being, kind of, like I said, tightly integrated with that business strategy.
The other thing, leaning into what Kyle just said, is that a lot of organizations hire a bunch of data science talent and feel like, okay, my job is done. AI magic at the other end, right? And then they realize, oh my God, it's been like 10 months. I built this model in 3 weeks, but like a year later, I still don't have an application. And why is that? It's because I think too many organizations don't realize that AI is not conventional software. This stuff is not built, prototyped, deployed, validated at all like conventional software. It's highly experimental. It's highly iterative, as these guys been saying. There is a lot of repetition, and it's even when you deploy it, it still requires a human in the loop to verify if your model is performing within parameters or if it's drifting because your data is drifting. So, what's missing, and what I think why so many organizations are falling into this thing I call model debt, right? This increasing cost spent to build models that actually never get deployed. I think that it's happening because they're missing something that IT fundamentally does really, really well, and that's DevOps, right? It's that happy confluence of DevOps practice and culture and rigor combined with AI application development. And data scientists don't know this stuff, right? They're not, software engineers. They don't know robustness or scalability or security. But if we as IT guide them and integrate their workflow within kind of DevOps practices, then chance for success is so much better. So IT has a hugely valuable role to make that happen.
I'll tell you, Tony, that there's an implied statement in there is that IT knows how to do DevOps. And what we find is that there's different parts of the journey that many IT organizations are in their adoption of DevOps, all right, and agile methodologies and all that other stuff, right? So it's not a requirement that you do DevOps in order to do what we've been talking about. It's a ton better if you do it, right? And I completely agree with you, right? But it's okay to start with a environment where DevOps is just in the beginning parts of the journey, and maybe this is an enabler for actually justifying the journey that you have to take in order to adopt DevOps, because that's a cultural shift both within IT as well as the development organization and the business, right? But it's also a technology change, because you're going to have to now implement different systems for managing your source code, systems for managing your orchestration of your containers, all the things that Kyle does day in and day out by making sure the Kubernetes is running, the NGC, which is the NVIDIA GPU cloud, which is the software repository that NVIDIA provides. All of those elements need to be done, but they don't have to be in place. It's okay to start with a smaller project and move your way up and then turn it into that exactly what you talked about, right?
Yeah, that quick win is a very valuable way to get started. Many struggle with how to get started. You're absolutely right. They shouldn't kind of miss the opportunity to get their feet wet and deploy some low-hanging fruit use case. And the other thing that's really important in what you said is that, the insight team, the expertise you guys bring, can kind of hand guide folks through this journey and how to, achieve their business transformation, how to enable AI, and probably evolve their IT to get into that kind of rigor and discipline that's been missing.
Yeah.
So you're saying there's more to this than just technology?
A lot of pizza. Pizza's important.
Well, it's a common theme here, because and that was kind of what I was driving at earlier, Kyle, with the question I threw back at you, was there's more than just the tech side of this. I think getting IT to engage the rest of the business as an enabler instead of an order taker for infrastructure and those kinds of things is really what I think we're all kind of pushing for, that evolution, because there's so much more. There's that tribal knowledge that IT has about how to enable, and from a DevOps perspective, to your point, Terry and Juan, how we get these things done. Tony and Juan, how we get these things done it's more than just the tech side of things. And I really, we love you guys. We want to help you guys get, further with the mission that the organization is trying to accomplish.
So let me throw another thing in there too. One of the other assumptions that, Tony, you threw out there is that an organization has data scientists, right? And that is not necessarily true, right? There might be organizations that have an AI project that needs to be tested out, right, or proven or whatever, but is missing that person that's got the expertise to go and do the modeling, right? And there's really two paths for that one. One of them is that there's already a whole slew of things that have been pre-done for you that are literally just glue things together that NVIDIA provides out of that thing that I briefly mentioned, the NGC. So pre-trained models, pre-trained data sets, and those kinds of things that could make, and I'm going to use air quotes here, a regular developer, right, an AI developer, because they can just glue these things together and prove out, that gets me to 80% of the way there, 90% of the way there. Maybe I do need to bring in somebody that can get me from 90 to 100, right? And that could either be a resource that you bring on board yourself, or we have our own teams that offer services to do those kinds of things. So we have our own data scientists, data architects, data prep people, and all that. But either way, you don't have to start with the assumption that you have a data scientist, right? You can start with like, hey, I have a theory to test. Can I draw it and things? And you can. Absolutely, you can. And there's lots of great tools that NVIDIA provides for that.
Thankfully, the state of the art now is evolved to the point where we have these libraries that people can just pick off the shelf and use, because most of the popular low-hanging fruit type use cases have already been, kind of put into that library of, pre-trained models, as Juan pointed out, scripts, and really everything that you would need to get that quick win, or at least get closer to that quick win a lot sooner. So totally agree with what you're saying, Juan. I think we're beyond the point of having to need an army of data science talent. And I think the best strategy, honestly, is being able to take folks from within, the analysts who already work and live and breathe your data sets today and understand your business problem, arming them with the right tools and software combined with expertise from insight and infrastructure, that we're putting together, and being able to groom from within and get kind of citizen data science talent from people who've had some of those quick wins using all these tools and capability.
Absolutely.
Thanks. So we've kind of run the gambit here. We talked about having a team of data scientists, and to the fact that I have something I want to prove. I have a theory that I want to prove, kind of thing. I'd love each of you to kind of comment on where would you get started, regardless of where, or maybe you can kind of say a point. If you're already here, what's a good kind of place to get started? Because I think a lot, again, business, the C-level folks think a lot of AI, it's either built into something I've already got and I don't need to worry about it, or when somebody asks me about it, we'll figure it out at that point. Where do we get started?
I think you need to pick Tony mentioned this earlier, some low-hanging fruit. Pick a small problem to solve first. We've kind of mentioned earlier that there's going to be a ton of experimentation and probably a lot of failure, frankly, up front. And so if you try and chew off too much at once, it doesn't look like you're making much progress. So I'd say first and foremost is to start small, and also AI really needs executive sponsorship, some leaders that are on board with it, or else it's probably not going to get off the ground if you don't have that executive sponsor.
I think it's probably safe to say like before, if you're not thinking about cloud, somebody in your organization is, and it's probably the same from an AI perspective.
Absolutely.
Go ahead.
Yeah.
So I'll add to that, and then maybe Tony, you can.
Yeah, sure.
So another way to follow what Kyle said is that you do have to start with a hypothesis from the business perspective. I want to solve this, all right? And then what you want to do is see do you have the data to solve that problem, or can you get the data to solve that problem? So as an example, it would be, hey, can I do better cybersecurity? You probably have the data. Your sensors out there are gathering stuff. It could be in your firewalls. It could be in your whatever it is. It could be physical systems. Doesn't matter. You have the data. Now you want to make sure that you've learned better. And that's a good hypothesis, right? And then you have the data set. Now you got to start verifying, can I actually solve that? And then go from there. And there might be a different approach where, hey, I would like to make sure that we have contact tracing happen automatically inside of our buildings. Well, you probably don't have cameras everywhere that you want to have cameras, right? You probably don't have ID badges and those things. So you might have to go and explore, how do I get that in place and generate the data and then train the model to do that, right? So both of those are fine, but you got to start with that presumption from the business, then see if the data is there, and then go through the training process. And there's actually a well-defined methodology called CRISP-DM. We follow it ourselves. CRISP-DM, that follows that whole life cycle, and it's really hypothesis, data, yes, validate the data, test, can I actually solve the problem? Did I solve the problem? If I didn't, then go back and get another hypothesis and go from there, right? And so that's maybe just a general answer to that of how to approach this, but start with a business hypothesis is my advice.
I like that. And let me just interject one more thing. Sorry, Tony. But you made me think about something, because, how unique does my business problem have to be to where I feel like I have to solve it myself? Is there value in if there are potentially commercial off-the-shelf solutions? You talked about security, so I kind of think about that a lot. How unique does my problem potentially have to be to investigate solving it on my own, if you will?
That's a really good question, and there's an art, all right? There's definitely edges to where people have actually taken this AI thing too. All right. So if you're trying to build something that understands natural language processing, that's probably something you should buy off the shelf, because there's researchers at Microsoft, at Google, and at AWS. They're pouring billions of dollars into learning how to do that, and they publish this stuff. So just use their stuff, right? If you're going after something like security and you have a very specific mission around how your security measures are being constrained, you're probably not going to find that built into anything. You're probably going to have to do your own research around that, right? So do some investigation how open and how big of a problem that is, and then you can probably find either off the shelf or off the shelf that you then have to customize with some smarts that Nvidia brings to the table.
Rock on. Tony, sorry to interrupt, man.
Yeah, no, it's. I totally agree with what both guys were saying. Kyle and Juan, I think it makes absolute sense. And I think the only other color I'd put in here is think of this as a team sport. It requires a number of different skills that kind of need to be brought together. I think Kyle's point on the exec sponsorship is so important, because starting with the premise of kind of the low-hanging fruit, a pragmatic, practical use case that has business impact, that can deliver tangible results that somebody can see and then champion, is so important, because inside of a large organization, that can create like a flywheel of success, right? Because you get that quick win, this team learns some things along the way, right? How to go from a ideation, from a concept to a production application. It's like muscle memory. And then they get to tackle more complex, bigger problems as the flywheel spins, and the exec sponsor can champion bigger and more resources and budget to do bigger and bolder things. But definitely think about who's in that team. Think about, obviously you need like a business analyst. You need someone who can also help wrangle the data, understand, as Juan had put out, where it is, where it resides, how it's accessed, cleansed, transformed, labeled, manipulated, such that it can feed this whole development process, right? And
I was staying away from that because I thought that could be a whole session on its own.
Right. Yeah. I'm not even going to try and go there, but think about.
We haven't even talked about the pipeline that Tony's talking about, which is how you make it from one stage to the next. So we could actually absolutely have a whole session on just the AI pipeline and how to manage it end to end. Sorry, Tony.
Sure. No, you're absolutely right, but that's the thing, right? It's this end-to-end life cycle that requires kind of this multidisciplinary team that knows how to bring it from one end to the other. At the very tail end of that, there's probably an application developer who knows how to hook this great model into like an API or web service, or wrapping it in code or what have you. That's where rubber hits the road, right? But I think people definitely need to be thinking of that versus taking some, poor grad student or something, say, hey, go get some AI, built for this particular problem, and then come back 3 months later and find out they're hurting. So yeah, that's the only other color I'd offer on this.
Fantastic. Well, gents, it's been quite fun. Any closing remarks from anybody?
Well, I'd like to just thank Tony for sitting in with us today. I really appreciate it. It's been a great working relationship, and we really appreciate the time you spent with us today.
Absolutely.
Yeah, just
thank you.
Want to say thank you to you guys for putting this together. Insight is such an important strategic partner to us, to Nvidia, obviously at the end-to-end level, but also for myself, within the DGX business unit. Insight has been instrumental in helping us kind of democratize AI for so many organizations. So we couldn't be doing what we're doing without this partnership. So thank you for putting this together and for having me on.
Awesome. Well, thanks, guys. I mean, I hope you folks out there have been enjoying our conversation, leaning into AI and the rewards that can come from that, the transformation organizationally that you can see from that. Thanks a lot to Juan, to Kyle, and to Tony from Nvidia for joining us today. If you'd like more information about the types of things that we do here at Insight, please visit us at insightcdct.com. Have a good day.